So 9-2, now we're going to add and subtract these rational expressions. Okay, that's all we're going to do with them. We're going to multiply them, divide them, add them, and subtract them. Okay, well, think back to, again, 3rd and 4th grade math. Just simple fractions completely. What do you have to do or have in order to add and subtract fractions? What?
Least common multiple.
And what do we call that when we add and subtract fractions? What does the least common multiple get us? Okay, so let's think about some numbers. What if I wanted to add 1/3 and 3/4?
Make the bottom.
You have to have the bottom the same, right? We have to have a common denominator. What would the common denominator be of 3 and 4? 12, right? So we're finding the smallest number that's a multiple of both 3 and 4. That's our least common multiple, right? So if we were actually going to do this guy, we'd make that guy 12, and we'd make that guy 12, and we'd multiply 3 times 4 to get 12, so 1 times 4 is 4. And 4 times 3 is 12, so 3 times 3 is 9, so I get 13/12. Well, we're going to do the same thing and get the least common multiple, but of polynomial expressions. So, to find the least common multiple of 2 or more polynomials, you have to factor each one of them. The least common multiple contains each factor the greatest number of times it appears. Okay? Not the least. Think about if it's in 1, it's got to be in the least common multiple. Okay, so let's start out with just some binomials here. No, monomials, excuse me. So I have 9 p squared cubed, q cubed, that's hard to say, 6p q to the 4th, and 4p to the 3rd. All right, let's start with the numbers. 4, 6, and 9. What's the least common multiple of all of those guys? And you're going to say, I don't know.
36.
36, right? Perfect, let's try it. I'll pick the smallest one. Which one's the smallest one? 4. And what I would suggest, this trick always works. You can always start it with the smallest one and just start multiplying it by 2, 3, 4, 5 till you get one that works, right? So 4 times 2 is 8. That doesn't work for 6 and 9. 4 times 3 is 12. That doesn't work for 9. 4 times 4 is 16. Doesn't work for 6 and 9. Does that make sense? You got to find which one's a multiple of both. Okay, so 36. Then it says each factor the greatest number of times it appears. Well, I have a p squared, a p, and a p cubed. Which one's the biggest? P to the 3rd. And then I have a q cubed and a q to the 4th. Which one's the biggest? To the 4th. So the least common multiple of those guys is 36 p cubed q to the 4th. The trick is to think about it's a multiple, so I want the greatest number of times it appears. Okay, how about 15a squared c cubed, 16b to the 5th c squared, 20a cubed c to the 6th. 15, 16, and 20.
Is it just 240? I can't think of anything else.
It is 240.
Okay.
But how did you find that, Zoe? What did you do?
Add multiply 15 and 16 and then divided it by 20 to see if
See if it works? Yeah, that works too. So you could start with the smallest one. So 15 times 2, that's not divisible by 16 and 20. So no, that's not going to work. So finally she got up to 16. It is 240. All right, how about a squared, a to the, or sorry, yeah, a squared and a to the 3rd. Which one's the biggest? And then I got a b to the 5th. B to the 5th. And then I have c cubed, c squared, and c to the 6th. Okay, so those first two were just monomials, right? One-term things. But look at number 3. Those are trinomials. I've got to write them as factors, so I'm going to actually have to factor these guys. Okay, so let's factor x cubed minus x squared minus 2x. What do I do first?
Pull up the X.
Pull out an x. They all have an x in common. Okay, so then I'm left with x squared minus x minus 2. See if that guy factors. A minus and a minus is a minus and a plus. Multiplies to 2, subtracts to give you 1. 2 and 1. Okay, that was that guy. Let's factor this guy now. A minus and a plus is a minus and a minus. Multiplies to 4, adds to 4. 2. How else could I write that guy?
X minus 2 squared.
Those factors are exactly the same, right? So I could write it as x minus 2 squared. Okay, so I'm looking at this guy here and this guy here. My least common multiple. If it's in 1, it's got to be in the least common multiple. Okay, well this guy has an x, so he's got to be in my least common multiple. This guy has x minus 2 to the first power. This guy has x minus 2 to the second power. So we want the second one. Remember, the greatest number of times it appears. And then this guy also has a x plus 1. Okay, now, that's useful for helping us find our common denominator, right? Okay, so to add or subtract rational expressions, you must have a common denominator. Okay, so here's what we're going to do. My suggestion is that you always set it up this way. So, he's a plus, so there's my denominators. I want to get my denominators to be the exact same. So I have 6b and 14a squared b squared. We need to find our common denominator, our least common multiple of 6 and 14. Is 36 divisible by 14?
No.
All right.
Wait, no, it's 42.
42.
That's what I have on my calculator.
That's what he has in his calculator. So, 42 divided by 14 is 3. Perfect. Okay, that'll work, right? So 42. What else? A squared, b squared. Okay, 6b. What do you multiply 6b by
7.
to get 42a squared b squared?
7a squared c squared.
So I'm going to multiply this guy by 7a squared b, right? Think about what's new. He had a b. Now he's got 2 b's, so I need another one. He didn't have any a's, so I need 2 a's. If you do it to the bottom, you have to do it to the top. Okay. 14a squared b squared.
Probably 3.
What do you multiply 14a squared b squared by to get 42a squared b squared? 3. Whatever you do to the bottom, you have to do to the top. Now, the trick is that some of you are going to start to simplify there. If you start simplifying right there, you're going to go back to where you started. So don't do that. All right. So let's actually multiply this out. 35. A to the 4th B plus 27 all divided by 42 A squared B squared. Why aren't we what? The 42, when you add fractions, remember you just have the denominator once. So you keep the denominator and add the numerator. So think about when we did it up here at the top. Right, when we were doing it with these guys, we kept the 12, keep the denominator, add the numerators. Same thing. Keep the denominator, add the numerators. Okay, so let's try 5. We probably need to factor our denominators first, right? Okay, so if I factor my denominators, is there something that can come out of this guy right here? What can come out? A 3. Okay, so this guy factors into 3 times x minus 5. What can come out of that guy? So he turns into 6 times x minus 5. Okay, my least common multiple of 3 and 6.
Or 2.
Multiple.
3.
Bigger.
6.
6, right? They each have an x minus 5. Okay, that's not bad, right? So what's new over here? Multiplied it by 2. So 2 times x plus 10. Is anything new over here? So this guy's minus 3x plus 15. Okay, a few things. We are going to have to distribute this guy, but we also need to distribute the negative. Okay, so I can squish it together. They now have the common denominator of 6 times x minus 5. And then I have 2x plus 20 minus 3x minus 15. So I have a positive 2x and a negative 3x, so I get negative 1x. And a positive 20 and a negative 15, so I get a minus plus, 5. What do you see there? Take out a negative, right? Negative 1x plus 5 is the opposite of x minus 5. Okay, so let's factor out a negative 1. Now they have a common factor of x minus 5, so this guy reduces to just negative 1/6. Questions on those ones? I want to give you some time to work, and as I look at your worksheet, there's nothing really like 5, 6, and 7. They're pretty much like 4 and 5. Would you like to skip 6 and 7 and have more time to work?
Yeah.
Okay. Let's then look at the next page. Let's pick another one to do together. Does that sound good? So let's pick another one from your worksheet. So turn the page.
1.
I was 1.
Let's do one together. Okay, so the top ones, you're just finding the least common multiple. Okay, so let's do number 1. What's your least common multiple of 12 and 6? 12, okay. And I want that each variable, the biggest number of times it appears. C squared, D.
There's 1.
There's 1, okay. Pick another one from 7 to 22. What do you want to see down there?
20.
20. How do you feel about 20? Y'all want 20? Okay, let's go do 20. All right, as I look at this guy, I'm going to say, okay, x minus 5, he's already in his factored form. But how about this guy right here, x squared minus 3x minus 10? I don't want to hit that. I don't want to do that. Let's factor him. A minus and a minus is a minus and a plus. Okay, so it multiplies to 10, subtracts to give you 3. 5 and 2. I want a negative 3, so I want a negative 5 and a positive 2. I'm going to run out of room. I write too thick. I can feel it. Okay, so if I look at this guy and I set up my fractions, what's my common denominator? If it's in 1, it's got to be in the new one. X minus 5, x plus 2. Okay, well this guy already had a 2x plus 1. So what's new over here? X plus 2 is new. So if he's new in the bottom, he's got to be new in the top. On the right side, is there anything new? No. So I don't have to change anything. You already had a 4 in the top. If you cover it up right now, you should see where you started. Okay? Don't actually cancel them out though, but I want you to see that's where you actually started. Okay. So they have a common denominator. I can squish them together, but I'm also going to have to FOIL this guy. So here we go. I get 2x squared plus 4x plus 1x plus 2. 4, 1, 2, minus 4 all over my new common denominator of x minus 5x plus 2. Okay, combining like terms. I get 2x squared plus 5x minus 2 all over x plus 2. We might be done, but let's check our numerator first. Does our numerator factor? It'd be a plus and a minus, so it'd be a plus and a minus. Are there two numbers that multiply to 4 that subtract to give you 5? Multiply to 4, subtract to give you 5. That would add though, right?
Yeah.
So does he factor? No. Yes. Ray.
How did you cancel out the x minus 5 to just get the x plus 2?
Oh, I didn't. I forgot to write him. Thank you. Jillian, was that your question? Sorry. Thomas.
For the homework, can we do one column for 92?
No, you can do both columns. You'll have this cool thing called spring break. Yes, you could do the left column now and the right column tomorrow. How does that sound? Okay. Zoe, you said 5, right? Okay, so let's look at 5.
Or if you only have one column, you can do that Wednesday and have 2 tomorrow.
True. And then on Friday, you could go back and do the other columns. Okay, so let's look at 5. Can I factor t squared minus 5? Yeah, how's he factor? Yep. So if it's in 1, it has to be in the new one.
That's just the
So it is t minus 5, t plus 5. You're welcome. Okay, any other questions?